Today we're going to cover multiplying and dividing radical expression. The first part we're just going to cover multiplying with radical expression. Now when it comes to multiplying, here we're just going to multiply with its respective parts. So let's take a look at the example. I have the square root of 3 times negative 5 square root of 6. So when you're multiplying, and what I meant by multiplying by its respective part, we're going to multiply with outside and inside with inside. So here in the first part, square root of 3, it has that invisible 1. So when we're multiplying the 1 with the negative 5 because those are the outside. So it's going to be negative 5. And I'm going to put inside the square root. Now here, when I'm multiplying, I'm just going to group the inside part. So I'm going to group the 3 and the 6. I'm going to write 3 times 6. When you multiply, it's going to be negative 5 square root of 18. Alright, next is you're going to simplify the square root of 18. Always check if you can simplify the number that is inside the radical. So we're still going to have the negative 5 outside. Now for 18, I'm going to break it down to the square root of 9 times the square root of 2. The reason I'm using these two numbers is, again, 9 is a perfect square number. So when you're simplifying, you're going to have that square root of 9. So the square root of 9 will become 3, but we still have that 5 outside. Negative 5 and the square root of 2. So when you multiply, I'm going to multiply these two numbers. So negative 5 times 3 will be negative 15 and square root of 2. So that will be my final answer. Let me box that up. And to review with this example, I'll multiply with outside and inside with inside. Now I did it step by step to illustrate that inside the radical I was multiplying 3 and 6, which is how we got 18. And then we checked if we can simplify the square root of 18, which we can. Therefore I broke down 18 into 9 and 2. From there we were able to do the square root of 9, which became 3, and that 3 multiplied with the outside number, which is negative 5. Hence that's how we got negative 15 outside the square root. And then square root of 2, you can't simplify nor do the square root of it, so we have the square root of 2 and our final answer. Hence, our final answer is negative 15 square root of 2. In this example, we have 5 square root of 15 times negative 2 square root of 20. So, just like the last example, I'm going to multiply outside with outside and inside with inside. So, 5 times negative 2 will be negative 10. And we're working with square root. So it's going to be 15 times 20. So I'm still going to have the negative 10 outside. And then when I multiply 15 times 20, that is going to be 300. So after that, you're going to check if you can simplify or do the square root of 300. So here, I can only simplify 300. So I'm still going to have the negative 10 outside. And then when I break down 300, I'm going to have square root of 100 times square root of 3. And the only one that I could do the square root of is the square root of 100. So the square root of 100 is 10. I still have the negative 10 outside, multiplying, and I'm going to bring down the square root of 3 because that's in its simplest form. So I'm going to multiply negative 10 with 10. That will be negative 100, and then bring the square root of 3. That will be my final answer. Let me box that up. So again, my final answer is negative 100 square root of 3. In this example, we have 3 square root of 5x to the third power times negative 4 square root of 5x to the seventh power. So in this example, we're going to be working with variables and their exponents. So let's do this part by part. Just like the previous example, I'm first going to multiply the outside number, my 3 and the negative 4. When I multiply, it's going to be negative 12. And we're going to be inside the square root. So the first one is 5x to the third power times 5x to the seventh power. So let's multiply the inside. Again, I still have the negative 12 outside. Now 5x to the third times 5x to the seventh. So for the numbers, the 5's, when I multiply, I'm going to have 25. I'm going to have x. Now since it's x to the third times x to the seventh, it's the same base, I'm going to add the exponent. So 3 plus 7 will be to the 10th power, all inside the square root. Alright, I'm going to break up the 25 and the x separately. So I'm going to have negative 12, the square root of 25 times the square root of x to the 10th. Now, examining closely, you can actually do the square root of 25. It's a perfect square number. So let me bring that down. Square root of 25 is 5. Now, over here, with the square root, remember you have that invisible 2 as your index. 2 can go into 10 5 times. So you can do the square root of x to the 10th, which will become x to the 5th power. So let me repeat. 2, which is our index, can go into 10, the exponent that is inside, 5 times. And I'm going to bring down the negative 12 because that was the outside number. So at the moment, we have negative 12 times 5 times x to the 5th. So we're going to have negative 60 x to the 5th power. So that will be my final answer. So in this example, we were able to get a perfect square number, which is 25. In addition, we got x to the 10th power, where the index 2 was able to go into 10 as a whole number 5 times. So in this answer, we just had negative 60 x to the 5th power with no radicals. In this example, we have 2 square root of 6v to the 5th power times negative 4 square root of 3 to the v to the 4th power. So I'm going to multiply with the same process. 2 times negative 4 first, which would be negative 8. And then I'm going to write 6v to the 5th times 3v to the 4th power inside the square root. I'm still going to have negative 8 outside. I'm going to multiply the inside, so 6 times 3 is 18. And then v to the 5th times v to the 4th. So since we're multiplying with same base, I'm going to add the exponent, 5 plus 4, which is 9. Alright, all of that is inside the square root. So right now I have negative 8 square root of 18 v to the 9th power. What I'm going to do next is I'm going to separate into parts. So we still have the negative 8 outside, but now we're going to have square root of 18 times v to the 9th power, the square root of v to the 9th power. Now 18 is not a perfect square number, so I'm going to separate into 2 factors, which is the square root of 9 times the square root of 2. And then for the square root of v to the 9th power, remember we have that invisible 2, 2 cannot go in 9 as a whole number. So starting with 9, if I take 1 away, I'm going to have 8 left. 2 can go in 8. So I'm going to write v to the 8th power inside the square root times v to the 1 power that I took away. And I still have that negative 8 outside. Alright, so from this point, let's go back to the numbers. You can do the square root of 9, which will be 3. And then I'm going to bring down the square root of 2 because you can't simplify nor do the square root of it. Now for the v's, so again, with that square root, you have that invisible 2. You can do the square root of v to the 8th power because 2 can go in 8 4 times. So it's going to be v to the 4th power. My invisible 2 cannot go into 1 as a whole number, so I'm just going to bring that one down. So it's going to be times v, the square root of v to the 1 power. And I'm going to bring down the negative 8. So next, I'm going to multiply that are without the radical, so negative 8, the 3, and v to the 4th power. So when I multiply it all together, I'm going to get negative 24 v to the 4th power, and then the one with the radicals, I'm going to put it together, so it's going to be 2v inside the square root. So there, I'm going to box and make this as my final answer. Negative 24v to the 4th power, square root of 2v.